Hey everyone, this is Group 21 and we've been asked to obtain the unit step response of a unity feedback system whose open loop transfer function is giving us g of s to be equal to a fraction with a numerator 4 and a denominator s multiplying s plus 5. So in control systems, a unity feedback systems means that the feedback transfer function, which is h of s, is equal to 1. This means that the output signal is fed back directly and then compared with the inputs to reduce error and then improve the performance of our system. And to solve this problem, we first need to find the closed loop transfer function of the system using the standard formula. After that, the next steps will involve simplifying the expressions and then finding the unit step response. At this point, I'll pass it on to my colleague to show how we obtain the closed loop transfer function.
Hello, so I'll be presenting on the closed loop transfer function. So the usual closed loop block diagram looks like this. We have our R of S, which is our reference input, our E of S, which is our actuating input signal. We have our B of S, which is our feedback signal, our H of S, which is our feedback transfer function, G of S, our forward path transfer function, and then our C of S is our output signal. Now, from our knowledge from block diagrams, we can see that we can get C of S by the products of G of S and E of S, and we can get B of S by the product of H of S and C of S. That's this. And then we can also get E of S by the sum of the input, the reference signal, and the feedback signal. Because it will be negative, so we'll have a minus here. So substituting these equations into themselves, we have B of S giving us H of S. We've substituted the equation for C of S into this, and then we've gotten our transfer function, our open loop transfer function, but we are looking for the closed loop transfer function, which has a feedback. And so we placed the E of S into the transfer function here, and then from there we substitute, and then we get our closed loop transfer function, which is G of S over 1 plus G of S H of S. But we are looking for the unity control system transfer function, and for that we have our H of S giving us one, and when H of S is 1, we get a transfer function of G of S over 1 plus G of S. Thank you very much.
Sir. Once the presentation, we substitute the transfer function to closed loop function. Then the formula I also have substituting this function. What do you think about everything? I'm going to get you. When you get to this point, factorize it plus 4. Thank you.
So, step 4 is about finding the closed loop transfer function. You start with the ratio of output and input in the control system. So, step 4 simply states the final simplified closed loop transfer function. What this means is 4 is the numerator, which means the system gain. S2 plus 5s plus 4 is the denominator, which represents the system dynamics. The denominator also determines stability and system response. So step 4 just shows that after simplifying the system, the overall transfer function becomes 4 over s squared plus 5s plus 4 into brackets. Then the next step uses this to find the output when the input is in.
So after simplifying our equation, we ended up getting 4 over s squared plus 5s plus 4 times rs, right? And we know that rs is a unit step input, right? And for unit step inputs, we know that what rs will become 1 over s. So our equation now becomes 4 over s times bracket open s squared plus 5s plus 4.
And s plus 4 in brackets. So c of s is equal to 4 all over s squared plus 5s plus 4. And that whole expression is being multiplied by r of s. Now r of s was given to us as 1 over s. So after you put 1 of s into the equation, you end up with 4 all over s multiplying the expression in brackets s squared plus 5s plus 4. So that you factorize the bracket in the denominator and then end up with 4 all over the product of s and then s plus 1 and s plus 4.
Okay, so from where my group member left off, we got our input function to be 4 over s bracket open s squared plus 5s plus 4, which is our input equation, our input function. Now since we have this, we're going to use partial functions to break it down into simpler terms. So now in the solution we have here, this is equal to 4 over s plus, so s bracket open s plus 1 close bracket open s plus 4, giving us 3 different terms in the denominator. With this, we can use our partial expansion to do it, which is equal to a over s plus b over s plus 1 plus c over s plus 4. Now solving this using partial equations, okay, we know that our a is 1, b is negative 4 1 3, and c is 1 over 3. How to solve this is with partial functions is that we create the left hand side to right hand side to make sure that each of the a, b, and c have a term attached to it. Now we make s equal to 0, 1, so 0, negative 1, or negative 4 to find the values of a, b, and c. So now we are done. We have our input function to be 1 over s minus 4 over 3 s plus 1 plus 1 over 3 s plus 4. Thank you.
I'll be explaining how we are going to use the inverse Laplace. So from the equation we have cs is equal to 1 over s minus 4 over 3 s plus 1 plus 1 over 3 s plus 4. So we are going to use the inverse Laplace identities, where 1 over s is equal to 1, then 1 over s plus a is equal to e raised to the power minus at. So from the equation, 1 over s is going to be 1. Then we are going to factor out 4 over 3. so that a will be equal to 1. Then we'll have the resulting equation as 4 over 3 multiplying e minus 80 plus 1 over 3 e minus 4t. Thank you.